Hello everyone, I am Ptsp from second year EC department and my roll number is 24BQ1A0439. Today I am going to give a seminar about moments, variance and standard deviation. So first of all, what is a moment? A moment is a numerical measure which is used to describe different properties of probability distribution. It gives information about spread, shape and location of the probability distribution. In this there are two types. First one is moment about the origin and moment about the mean. Moment about the mean is also called as central moment. First one is moment about the origin. Let us consider g of x is a function and g of x is equal to x power n, where n is equal to 0, 1, 2 and so on. As we know that the expected value of g of x is called the moment about the origin and it is denoted with mn. As we know that e of x is equal to integral minus infinity to infinity x into fx of x dx. So if we substitute g of x in that equation, e of g of x is equal to integral minus infinity to infinity g of x into fx of x dx. So for continuous it is mn is equal to e of x power n is equal to integral minus infinity to infinity x power n into fx of x dx. And for discrete it is mn is equal to e of x power n is equal to summation I is equal to 1 to n xi power n into p of xi. If we substitute n is equal to 0 in continuous equation, it becomes m naught is equal to integral minus infinity to infinity x power 0 into fx of x dx. We know that x power 0 is equal to 1 and it gives value 1. Therefore, the 0th moment m naught is equal to 1, which gives us the area under the probability density function. And we substitute n is equal to 1 in that equation. m1 is equal to integral minus infinity to infinity x into fx of x dx, which gives us mean. Therefore, the first moment m1 is equal to mean, whereas m1 is equal to x bar. And if we substitute n is equal to 2 in the continuous equation, m2 is equal to integral minus infinity to infinity x square into fx of x dx, which gives us mean square. Therefore, the second moment represents the mean square value of the x. If we consider x be the random signal and m1 gives us average value of the signal and root m2 gives the RMS value of the signal, and the second one is moment about the mean and it is also known as central moments. Let us consider g of p the function where g of x is equal to x minus x bar whole power n, where n is equal to 0, 1, 2 and so on. The expected value of g of x is called the moment about the mean and it is denoted with mu n. Therefore, e of g of x is equal to integral minus infinity to infinity g of x into fx of x dx. And for continuous it is mu n is equal to e of x minus x bar whole power n is equal to integral minus infinity to infinity x minus x bar whole power n into fx of x dx. And for discrete it is mu n is equal to summation I is equal to 1 to n xi minus x bar whole power n into p of xi. Let n is equal to 0 in continuous equation, it becomes mu naught is equal to e of x minus x bar whole power 0 is equal to integral minus infinity to infinity x minus x bar whole power 0 into fx of x dx. Therefore, e of 1 is equal to integral minus infinity to infinity fx of x dx. Therefore, the 0th moment gives us unity value and n is equal to 1 in the equation. It becomes mu 1 is equal to e of x minus x bar, which is nothing but integral minus infinity to infinity x minus x bar into fx of x dx. If we separate the two variables, which is x and x bar, it becomes integral minus infinity to infinity x into fx of x dx minus integral minus infinity to infinity x bar into fx of x dx, which gives the value 0. Therefore, the first central moment is always 0. And the next one is variance. The variance of a random variable describes how much the value of random variable x deviates, which is nothing but spread from the mean x bar, and it is denoted with sigma x square or variance of x. For continuous, it is mu to x is equal to mu of x minus x bar whole square is equal to integral minus infinity to infinity x minus x bar whole square into fx of x dx. Whereas for discrete case, mu2 is equal to summation I is equal to 1 to n x minus x bar whole square into p of xi. So the final topic is standard deviation. Standard deviation is calculated by the positive root of the variance, and it becomes sigma x is equal to root of e of x minus x bar whole square. Thank you.